Gas station, there are n stations in a circle. At I you gain gas of I units of fuel, and moving to the next station costs cost of I, return a starting index that lets you finish one full lap clockwise, or -1 if it is impossible. Example 1, gas is 12345 and cost is 34512. The answer is station index 3. If you begin there, you can complete the circle without running out of gas. Earlier stations fail as the only start. Example 2, gas 234 and cost 343. Total fuel available is 9, total fuel needed for the lap is 10, so no starting station can work, return -1. Before we simulate a lap, check the books, add every gas and subtract every travel cost around the full circle. If the total fuel available is less than the total fuel required, the circuit is impossible and we return -1, there is nothing left to search for. Watch the yellow line, that is the running balance after each leg if you begin at station 0. Tick marks show the leg index and the balance, the yellow numbers sit on each vertex. The red ring marks the deepest dip. The green label names the first station that can finish the lap, here, station 3. Here is the key lemma. Suppose you start at station 0 and run out before reaching station 3. Then station 1 and station 2 cannot reach station 3 as a sole start either. When you crossed each one you already had non-negative extra fuel in the tank, and you still failed later. Starting there with an empty tank cannot be easier. Algorithmically that means a single linear scan. Keep a candidate start and a running tank. If the tank ever drops below 0, abandon everything up to here, set the next candidate to the station right after the bad leg, reset the tank, and keep walking forward. With non-negative total surplus, the last surviving candidate completes the circle. We keep a global running total, at each index, add gas of I minus cost of I. If this finishes negative, the circuit is impossible. Here it ends at 0, so some start works. Next we track a greedy tank to find which index. Now simulate from an empty tank at the candidate start. After leg 0, the tank reads -2, you cannot complete the lap from station 0 or any station you already passed with fuel to spare. Reset the tank to 0 and set the candidate start to I+1. You are not revisiting old stations, you are skipping a whole failed prefix. Legs 1 and 2 are still net negative. Each time the tank drops below 0, discard everything so far and try the next index. The candidate lands on 3. At index 3 the net turns positive, and the tank stays non-negative through index 4. We already know total surplus is 0, so this candidate completes the circle, the answer is 3. N is the number of stations. We make one linear scan and do constant work per index, so time is O of n. We only keep the running total surplus, the greedy tank, and the candidate start index, so space is O of 1. Define the function, given parallel gas and cost arrays, return a valid start index or -1. N is the number of stations. Initialize the full circuit total surplus, the greedy tank, and the candidate start, all at 0. Loop each index I from 0 to n-1 exactly once. Delta is net fuel on this leg, gas at station I minus the cost to reach the next station. Add delta to total, that is the running sum of gas minus cost around the whole circle. Add the same delta to tank, fuel remaining if we started the scan at the current candidate. If tank is negative, no start in the skipped prefix can complete the lap. Advance the candidate to the station after this failure, I+1. Reset tank to 0, we do not backtrack within the loop. After the loop, if total surplus is negative, the circuit lacks fuel overall. Return -1. Otherwise return the surviving candidate start index.